The question says, the rotating part of an electric motor, on starting achieves an angular velocity of 1,200 revolutions per minute. 1,200 revolutions per minute. That is what the motor achieved in rotation. He achieved that in 10 seconds. He achieved that in 10 seconds. He said that the rotating part of an electric motor on starting achieved an angular velocity of 1,200 revolutions per minute in 10 seconds. Time is 10 seconds. In 10 seconds, he achieved this. So the question says, determine the angular acceleration of the rotating part. The angular acceleration will be equal to the angular velocity over time. The angular velocity, and this is the angular velocity. And time is in seconds. So this is 1,200 revolutions per minute. And one revolution is 2 pi, if you remember. 2 pi radian. One revolution is 2 pi radian. One revolution is 2 pi radian. One revolution is 2 pi radian. So that means 1,200 revolutions per minute will be 1,200 times pi. You know, pi times 2 pi radian. Times 2 pi radian over, we want to change it to seconds, over 60, because there are 60 seconds in 1 minute per minute. So that is the angular velocity. 1,200 times 2 pi over 60. That will give us the revolutions. That's the number of radians per second. The number, we have changed the minutes to seconds, 60 seconds, and changed the revolution to 2 pi. So we can now get our answer in radian. Per second. So this is the angular velocity. This is the angular velocity. Now to get, that's the angular velocity. Now to get in radian, this is angular velocity in radian per second. Now to get the angular acceleration, which is what the question demanded, will be divided by time. Angular acceleration will be 1,200 times 2 pi over 60. And what time? Time is 10. 10 seconds. Time is 10. That's the angular. And that gave 12.56 radian per second square. 12.56 radian per second square. 12.56. So the question says, the rotating part of an electric motor on starting achieves an angular velocity of 1,200 revolutions per minute in 10 seconds. So what we do is, then he said, determine the angular acceleration of the rotation. Already he has given us the angular velocity, which he said is 1,200 revolutions per minute. So the only thing is that the time was given to us in seconds. So that means this has to change to seconds. So if we divide by 60 per minute is 60 seconds. We divide by 60. We want also to change it from revolution to radian. But one revolution is 2 pi. That's why we multiply by this. So this is still the angular velocity. So on dividing it by the number of time, because angular acceleration is equal to angular velocity divided by time. So that's exactly what we did to get the answer to be 12.56 radian per second. A rotating part of an electric motor on starting achieves an angular velocity of 1,200 revolutions per minute in 10 seconds. Determine the angular acceleration of the rotating part of the machine.